Okay, so in this experiment, what I did is I created an animation inside of Poser, and basically all I did was I moved this one hand, and the animation is basically a 24-frame animation. All it is the hand being moved up. I made sure that's the only thing that I tweaked, because I want to make sure everything else stays the same, because I know there's a lot of data, and I want to know exactly what this stuff is. I've never actually played with VBH files like this before. I have no idea what their structure or how it works, but after exporting it from Poser, export VBH motion, it tells you how you want to export it. I ended up with this VBH file that I can open up inside of VBH Hacker. If you click play, well, there's my animation, my motion capture file, and sure enough, it says there's 24 frames per second running at, well, it's 24 frames long, running at 30 frames per second, and I believe I can select the right hand somewhere in here. That's the left hand. Waist, right collar, right hand. There it is. So you can see the different values going up and down as the frames go. Anyways, opening it up inside of Notepad++, we can see that this is basically what it looks like. It has all the offset stuff predefined, and I still have a lot to learn about this. I don't know what any of that means, but right here it says that it's 24 frames long, and this is the speed, so that's 30 frames per second right there. Each frame is 0.03 basically milliseconds, I believe, or 0.33 1/100ths or 1/1,000,000th of a second, something like that. I don't know too much about this, but I can tell that this is frame 1, 2, 3, 4, 5, 6, all the way down. So that's 24 frames. So basically the frames are written from top to bottom, and it's really hard to kind of figure out what's what. So it's a good thing that I didn't move anything other than the actual hand. So what I did next is I went into a spreadsheet where I copied those frames, and I just kind of went up and down, just kind of, okay, see if anything changes. As I scroll up and down, because nothing is moving, those numbers stay the same until you reach this particular section right here. So this is kind of how I sorted it out, because I don't know, as I scroll up and down, the fact that this stuff is scrolling, it kind of shows that those numbers are moving. So that's how I determined where that wrist was. It's kind of a grunt way of doing it. But now that I know where that wrist is located, that hand is located, I know that this is probably X, Y, Z. I'm guessing. I still don't know yet, but I'm assuming. Anyways, I'm calling any numbers that go before here, I'm calling it the front, and any number that's behind here, I'm calling it the back. And this is going to be my XYZ coordinates for the hand, and since I only have one node, that's where we're going to be stuck at. So inside of my Arduino code, I'm basically printing out something that reads front, followed by a space, and the X coordinate, the Y, and the Z, and then followed by the word back. And let's see if we can launch it. And I have my Arduino set up so that once I press the button, it starts recording. So it only records for the duration of the button press. So this could actually be useful when used inside of a suit, so that the actor himself can record his movement. Or you can record it yourself if you're doing this on your own. So I'm going to start recording now on 3, 2, 1. Okay. So now it's laying down these motions. I'm just basically moving my hand up and down, left, right, tilting it, and I'm just pressing and holding the button down. Okay, I'm about to let go of the button. Boom. So I stopped recording at that point. Now the reason I left out all that other stuff and just replaced it with front and back is because there's so much data that it causes the display to run slower. So this was my solution for that. So what I'm going to do next is I'm going to take this readout, I'm going to copy it, Control C, and bring it into, let's see, I'm going to bring it into a new file, paste it. Now right off the bat, because Notepad numbers every line, I can already see that there's 569 lines, so that's 569 frames that were recorded at 30 frames per second. Oh, that's the other thing. I actually told it to not do anything for that amount of time. There's the delay right there. And I may have done that wrong. Let's fix that real quick. Let's see here. Because I may be wrong on that. Yep, my timing is way off. So let's go back to our Arduino code here and let's kind of redo this. We want each event to only happen at this interval. Alright, let's reprogram our accelerometer. We're going to delete this and we're going to try again. Okay. So I'll press the button. Make sure it got uploaded. Yep, it's completed. Alright, here we go. Up, down, left, right. And my coordinates could be off, so all I'm doing is slowly moving it around. Alright, that should be enough. So now I'm going to take this data, copy it into a new file, and there's like a double space right there, so first I'm going to fix that. And replace it with a single space. Okay, so now we're going to take the front and replace it with our front section. This is all manual rebuilding. I mean, obviously the ideal solution would be to come up with a way to automate this whole process, which I probably can do. Let's see, we're going to replace it with this, paste, oh, here. Alright, and if you look over here, you can see that it's 550 lines of data. Well, not including these. I'm going to get rid of this. Alright, make sure that was taken care of. So all of them have that in the front. And it's 548 lines of data with everything in the front and the last three coordinates for the XYZ for the stuff that we recorded. Now let's add the tail or the back part of it. see here, copy from here to here and replace every instance of the word back. With the new data, replace all. So now, we I ended up with 2 empty spaces there. Let's see. Control A, space. Alright, that fixes that. So now I have an entire series of frames in the format that it expects. At this point, we're going to go into our hand motion file here. We know from looking at this that we have 548 frames, 548 lines. 548. We're going to replace all this with the new data, and we're going to save it. And now, this was the previous one. We're going to run it again. And here's the new one. It's all shaky and trembly, and it's working. I mean, we have new data that was provided by the accelerometer. So at least we know what we're targeting. So there you have it. We've managed to create motion capture data with our accelerometer and a little bit of manual stuff. So figuring out the math and getting all this stuff to translate properly might be more difficult than it seems. But at least I think it's a step in the right direction. I don't know. Maybe Perception Neuron will release their thing soon, and I don't have to worry about building my own. All right, that's it.